Statistics is an integral part of the data analytics and the data science journey. If you are one of the enthusiasts and you want to make a transition to the data analytics or the data science domain, you need to definitely know about statistics. But there are so many topics inside statistics, understanding each one of them might not be possible for a data scientist because we are mostly concerned about the practical applications, but definitely the theoretical knowledge of statistics is needed. Welcome back to this channel. In this video, we are going to focus on what are the various statistics concepts that you need to learn in order to become a data scientist or a data analyst. So let's get started. Let's get started with the topic statistics for data science. We all know statistics is very much important for data science and data analytics enthusiasts because it's all about statistics. It's all about how you use your statistics concepts in your day-to-day activities while performing data analysis or while creating a model. So, statistics and mathematics plays a vital role. Let's try to understand the importance of statistics in data science. Statistics is a fundamental component of data science, no doubt about it. It provides the tools and techniques to analyze and interpret data. Statistics helps in making data-driven decisions and drawing meaningful conclusions. It also enables us to uncover patterns, trends, and relationships. Now, talking about the next steps, what is the role of statistics in deriving insights? In order to derive some insights, in order to perform some exploratory data analysis, statistics concepts are very much needed. How they are needed will be discussed in the next slides, but they are very much needed. Statistics plays a crucial role in deriving insights from data through various methods such as descriptive statistics and inferential statistics. So in general, if I talk about statistics, statistics is of two types. One is descriptive and one is inferential. What do you mean by descriptive? That means summarizing and describing data using some measures like mean, median, mode, standard deviation, variance, finding the correlation, covariance, and so on. The second type of statistics is inferential. As the name suggests, inferring from something, drawing conclusions from something. So drawing conclusions and making predictions about a population based on a sample using techniques like hypothesis testing, confidence intervals, p-values, that's basically your inferential statistics. Let's get into descriptive statistics. What exactly is descriptive statistics? Descriptive statistics summarizes and describes data in a meaningful way. If I further divide descriptive statistics, they are divided into multiple concepts like measure of central tendency, the measures of dispersion. Now, measures of dispersion and central tendency. What do you mean by central tendency? The measures of central tendency basically helps you to identify the center of the data. If you know your data and you know the center of the data, you probably might know that most of the data points will be around the center of the data. So that basically helps you in identifying the center of the data. Measures of central tendency. And how do you find center of the data? You find using concepts like mean, median, and mode. What do you mean by measures of dispersion? That means how your data points are dispersed. So various concepts like range, interquartile range, and various other concepts are required like variance, standard deviation. These all are needed in order to identify the dispersion of the data. So some of the key measures includes mean, which is the average of the data set, median, mode, standard deviation. Let's try to calculate mean, median, and mode using a simple example. So let me take an example. Let's say 5, 10, 7, 9, 3, 5, 6. In order to find the mean of these values, Mean is the simplest measure. You just have to take the average. Now, what is the average here? The average is going to be 5 plus 10, 15, plus 7, 22, plus 9, 31, plus 3, 34, plus 640, plus 5, 45, divided by 7. So let's take it one more number so that it is divisible properly. So we have 45 and we have 7 attributes. So let's take 3. So now it becomes 5 plus 10, 15, 22, 31, 34, 39, 45, 48. So the average is going to be 48 divided by the total numbers 1, 2, 3, 4, 5, 6, 7, 8. Now if you divide this becomes 6. Right? So the mean or the average is basically 6. Now, what is the median here? Median is usually the medium value, the middle point, the center value. Now, in order to find the median, you have to first sort the values. Let's sort it out. We have two threes, so I'll make it 3, 3. Then we have 5, 5. I'll make it 5, 5. Then we have 6, 6. Then we have 7, 7, 9, and 10. How many values do we have? 4 and 4. So what are the middle values? The middle values are 5 and 6. Now when you have odd numbers, then the middle value is the exact middle value. Let's say you have 5 digits. 1, 2, 3, 4, 5. Here the median is going to be the middle value. But as in this case we have 8 values, there are 2 middle values, right? So the median will be 5 plus 6 by 2, which will be 5.5. What will be the mode in this case? Well, in this case, the total number of occurrences of a single digit. So 3 is occurring twice and 5 is occurring twice. So this is a case of bimodal situation. So your mode can be either 3 or 5. And that is how you calculate your center measures of central tendency and mean, median, and mode. Now you must be thinking, in which scenarios do we use this? Practically speaking, when you deal with data, when you are analyzing the data, you are doing some exploratory data analysis. In that case, there might be scenarios where most of your columns are having null values. Most of the rows are having null values. So whenever you have null values, in order to impute the null values, you can use any of these techniques. Now, we'll take an example for that. Let's take an example on how you can impute the null values. Let's say you are analyzing a particular data. One of the columns is age. Now, the first customer is 21 years old, 23 null, 23 null, 25 null, 21, 23. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's take one more. There are 10 records, out of which 1, 2, 3. 3 records are null. So we have 30% null values in this particular column. Now, some of the thumb rules says that if you have 30% or 40% of your null values, then you should impute them rather than deleting the column. If you have more than 50% or 60% missing values, deleting a column could be one of the options. But in this particular scenario, in this particular case, we will be imputing the missing values. Now, you can impute the missing values either by using a mean technique or a median technique. First of all, let's calculate the mean. What will be the mean? If you calculate, it's 44, 67, 87, 92, 192, 112, 113, 136, 136, 161. 161 divided by 7. I can cross check using a calculator. 21 plus 23 plus 23 plus 25 plus 21 plus 23 plus 25, which is 161. Divided by 7 is 23. So the mean becomes 23. So you can either impute them using 23, or you can calculate median, What will be the median here? My bad, the spelling is wrong. median. In order to find median, let's try to sort it out. 21, 21, done, done. 23, 23, 23, 23, 23, 23, 25 and 25, 25 and 25. The median value is 23. So the median is also 23. So you either impute it using mean value or median value, it is still 23. If I talk about the mode value, the mode is also going to be 23. So I mean, I just took an example and luckily we found that mean, median and mode all are 23. So you can use any of these techniques. In scenarios where you will have different values, you don't panic, you can use any of them. But it is always advisable to use either a mean value or a median value in a numerical data, in a numerical column. In categorical columns, you should always focus on mode values. I'll take an example of categorical data as well. Let's say I have a column called as gender. The first customer is female, then male, then male, then male, then female, then null. So in order to impute them, who is the mode here? The mode is female. Sorry, the mode is male. My bad. The mode is male. Male, male, and male. 3 occurrences. Female is just 2 occurrences. So as per the mode, you can impute them as male. So that is how you use your descriptive statistics concepts. Let's get into inferential statistics. What is inferential statistics? Inferential statistics summarizes and describes data in a meaningful way. There are multiple concepts inside inferential statistics that includes the concept of p-value, which is the probability value. We have hypothesis testing and confidence intervals. Now, let's try to understand what hypothesis testing is all about, because this is one of the most important topics in the field of inferential statistics. I'll take an example. Let's say one of my examples is we have a new drug. We can take a scenario of coronavirus. Let's say coronavirus is in the world right now. I'm imagining we are in 2020. So coronavirus has affected the entire nation, and there is a new drug that has been created by one of our medical agencies. So whether the new drug is effective or not. Okay. Now, we start with a null hypothesis. Inside hypothesis testing, there are two concepts that is very important. One is null hypothesis and one is alternate hypothesis. We kind of set our null hypothesis that the drug is not effective. If my null hypothesis is drug is not effective, our alternate hypothesis will be drug is effective. Okay. So we start with our statistical analysis using this concept. We set our null hypothesis and our alternate hypothesis. Then we perform some statistical tests. Now in the field of statistics, there are multiple tests that we do. That includes t-test, z-test, ANOVA, correlation test, and so on. Okay. And all these tests depend on your columns that we are using. If you are doing a numerical versus numerical, you can probably go ahead with a correlation test. If you're only analyzing a single column, you can do a t-test. If you're only analyzing two categorical columns, you can go for an ANOVA test and something like that, right? So there are multiple tests. The outcome of a test is a p-value. Okay. So we consider a p-value. If the p-value is less than equals to 0.05, then we reject the null hypothesis. If the p-value is greater than 0.05, we accept the null hypothesis. Now, you must be thinking, what is this 0.05? 0.05 is basically the significance level. Okay. And why do we set it as 0.05? There is a concept behind it. Most of the statisticians use 0.05, which basically means with 95% confidence rate. There is a theory behind how this number popped in. Now imagine you are tossing two coins. Okay. So if you toss two coins, let's say you toss one coin. Let's start with one coin. You tossed a coin. There are two chances, right? The sample space will be H and T. What are the chances of getting a tail? The chances of getting a tail is 0.5. When you toss two coins, HH, HT, TH and TT, what are the chances of getting two tails in a row? It is 0.25. It's just 1 divided by 4. If you toss three coins, the chances of getting three tails in a row is 0.125. When you toss four coins, the chances is 0.06. Now when you toss the fifth coin, the chances of getting a tail is 0.03. That means you are tossing 5 coins and all the instances you are getting tails, 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 right? So getting 5 tails in a row is just 0.03 chances. Now this is a scenario where people start doubting whether the coin that I am tossing, whether it is a fair coin or it is a manipulative coin. So some statisticians have decided that we will consider this as a significance level. That's why they consider 0.05, which basically means 95% confidence rate. So if you perform these tests and if your p-value is 0.05 or less than that, let's say your p-value comes to be 0.03. So you conclude that you are rejecting the null hypothesis, or you are simply accepting that the drug is going to be effective for the patients. So that's all about hypothesis testing. And while the journey of hypothesis testing, while explaining, you also came across the concept of p-value, and I hope the p-value concept and significance level concepts are also clear. Let's get into the concept of types of data. Now, majorly speaking, data is of two types. One is categorical and one is numerical. Now, categorical is treated or termed as qualitative data. You can also call it as qualitative data. And numerical is treated or called as quantitative data. So further, there are further two types of qualitative and two types of quantitative data. The two types of qualitative data is ordinal and nominal. Ordinal data is something that is in an order. Let's say in your data set, there is a column called as economic status. And the values are low, medium, and high. Now they are in an order, low, medium, and high. That's why they are called as categorical and ordinal data. Talking about nominal data, a data which is categorical but not in an order. For example, location. You have multiple set of customers who are staying in India, Canada, Hong Kong, and blah blah blah. So that could be your nominal data. Similarly, in the numerical aspects, there are two concepts. One is discrete and one is continuous. If I ask you how many students are there in the class, I mean, what is the total attendance? It could be 40, it could be 45, it could be 50. It can never be 40.2. It can never be 40.5. Number of students cannot be decimals. It will be a discrete number. So discrete basically means that. If something can have float values, let's say, what is the temperature, today's temperature? 37.2, 37.4. All these are treated or called as continuous numerical variable. Let's talk about data collection and then we'll also talk about sampling techniques. What do you mean by data collection? Now, as a data scientist or as a data analyst, you are bound to have the data in order to do the next steps, in order to perform the EDA, in order to perform the insight gathering, in order to do the modeling, and so on. So what are data collection techniques, or how do we actually collect data in a real scenario? Now, while explaining the real scenario, I'll also have to explain a concept like there are different types of companies. Okay, if I divide, there are MNCs, there are mid-level companies, and there are startups. Now, if you join a MNC or a multinational corporation, in big organizations, there are multiple databases and there are multiple owners of these databases. That means, let's say team A is the owner of this, team B is owner of this, and team C is owner of this. So if you join as a data analyst or as a data scientist, after you discuss the use case with your manager, with your senior folks, and so on, your next step is to let's get started with the use case. So in order to get started, you need data. In order to get the data, you need to get in touch with the data owners. So as a data analyst or as a data scientist, you go and talk to different teams and tell them this is what we are aspiring to do, and you get an access to the data. Some of them might give you a direct access to the database. Some of them might give you some flat files. Some team will say, no, we cannot give access to the data because it has critical information. So probably we need to mask the data or change the data or maintain the data privacy, and we can only give you 6 months of data. Will that be fine? If it is fine, you can take it. If it is not fine, you ask for more. That's how it is. But my main motive of telling this thing is, in big organizations, you might or might not get a similar type of data. If you are getting multiple types of data, let's say JSON from a team, DB access from a team, and files from a team, so you need to perform the data cleaning techniques and make the data structured. Once the data is structured, then you do your EDA, then your model building, and so on. But that's how the data collection works. In some organizations where you already have data warehouses and data lakes, there might be a data engineering team. In that case, it's very simple. Just go to the data engineering team, which in fact is your own team. You go ahead and tell them, they will be giving you access from a data mart or a data warehouse or a data lake, and you can work on your model building or the dashboard creation. So from organization to organization, the data collection techniques changes. Moving on to the mid-level companies. Mid-level companies might not have huge databases, but it will still have some databases, again owned by multiple teams, or in certain scenarios it could be owned by a single team. You have to follow the same steps, go and ask access. Coming on to startups, again there are two types of startups, one with a client and one without a client. Without a client, let's say you created a new startup, you are working on a generative AI use case or any data science use case, and you don't have a proper understanding what exactly my final product looks like. You are preparing a POC, proof of concept. You might or might not have data. In that case, you might have to rely on the public data sets. So you might take help of public data sets and then start creating the POC and showcase it to the customer, and then get the funding and start working on the real-time project. If you have a client, you might work on public data, or the client might give you access to the data. So depending on the type of company you join, the data collection technique changes. Now coming on to the next topic, which is sampling. Sampling is very important concept because ultimately, being a data analyst or a data scientist, we all work on sample data. Nobody works on population data. So what is the difference between population and sample? Now, population is nothing but the entire group of individuals or items of interest. And sample is a subset of the population. Now imagine you have 1 million customers data. You ask your database team, sir, can we have access to the data? We want to do some analysis and some model building. He will tell you, I cannot give you access to the entire data set. Probably I'll give you access for the last 6 months or 12 months, which contains like 10,000 customers. Will it be enough? Well, it's good enough for a POC. So you start working on it and work on your POC. Here, what's happening is this is your population data, this is your sample data. Now, how the samples are created, it depends from company to company, from team to team. Sometimes we are the owner of that part where we get our own sample, or sometimes the data owners give the sample to you, right? So conceptually speaking, there are different types of sampling techniques that includes simple random sampling, stratified sampling, and there are few other sampling techniques as well. There are techniques like there are probabilistic and non-probabilistic approaches. Simple, random, and stratified are probabilistic sampling. There are non-probability sampling as well, which includes research-oriented sampling, or there are some sampling techniques where you go and ask manually to the people. Purposive sampling. I was not able to recollect the name. Purposive sampling or research oriented sampling, and so on. There are various others. Talking about the probability sampling, we have simple, random, stratified, cluster sampling, and so on. Let's try to focus on these two. Simple random sampling is what the data owners do, the database owners do, and give it to the data scientist. They randomly get 10,000 records and they give it to you. That's simple random sampling. Stratified sampling is basically something like this. Let's say you are analyzing on a particular use case. I'll take one simple example. Let's say there is a column called as location. Now there are customers from Spain, Germany, and France. Let's say Spain is 30%, Germany is 50%, and France is 20%. You have 1 million records. So while extracting the sample, if you are considering location as a main column, if you're extracting 10,000 records, it should also have a similar proportion. That means 3,000 Spain records, 5,000 Germany records, and 2,000 France records. So that is called as stratified sampling, dividing the population into distinct groups and sampling proportionally from each group. So that's all about data collection and sampling. Next comes the most important topic for a data analyst or a data scientist. Whenever we start working on a particular data or a particular task, we always do this particular thing, which is EDA, Exploratory Data Analysis. Now, what exactly is EDA? In simple terms, EDA is nothing but insight gathering. That means we have the data, we need to perform some sort of analysis to get the insights. Now, while performing this step, we apply a lot of statistical concepts, including mean, median, mode. We need to understand standard deviation, interquartile ranges. We also plot some graphs like histograms, box plots. So let's try to understand EDA in depth. What are the techniques used in EDA? As I told you, techniques like measures of central tendency, measures of variability, graphical representations, and outlier treatment or outlier detection. But what exactly is EDA and how is the process when you work as a data analyst or a data scientist? How the process works and where does EDA lies? Okay, so whenever we start working on a use case, it all starts with business understanding. As a data analyst or as a data scientist, understanding the business problem statement is the most critical thing. Once you understand the business problem statement, then comes the data understanding. Now, imagine data understanding is that technique where you know what needs to be done and you are visualizing the thought that, okay, to achieve this particular task, these are the data that I need. And then once you know what sort of data you need, you go ahead and start collecting the data. So this is where the data collection starts. Now again, data collection we have already discussed. Data could be from a single source or could be from different sources. So you need to start collecting the data. The data collected after the collection part is usually unstructured data. Okay. So what is the next step? The next step is data cleaning. I don't want to write it as DC, it will be confusing. This is data cleaning. Now this is collection. Okay. Now once the data cleaning is done, what we do in data cleaning? Handling missing values, handling invalid data types, removing some rows and columns that are not required, and so on. After data cleaning is done, which you call it as a clean data, that is where EDA comes into picture. Now, while performing EDA also, you might realize something is wrong with the data. You can again come back to this step and again clean it and again go back to the EDA part. Now, this is where the task of a data analyst ends. Once your EDA insights are done, either the EDA insights are passed on to the data science team for the model building purpose, or the EDA insights are passed to the BI team for dashboarding. So this is where the EDA comes into picture, exploratory data analysis. Now we'll go a little bit depth into EDA. What are the different types of analysis that we do? Now in EDA majorly we perform three types of analysis. First is univariate, second is bivariate, and third is multivariate. Univariate basically means one variable. Now bivariate is two variables and multivariate is n variables. Now what do you mean by univariate? Let's take an example and try to solve this. Let's say you're analyzing 10,000 records of customers. Some of them have churned, some of them are not churned, not churned. Okay, there is a column that basically tells which customers are churned, which customers are active. I hope everybody knows the concept of churning. Churning basically means if you leave a company and join another company. For example, currently you are using Axis Bank or HDFC. Kotak gives you a new offer, you jump into Kotak and become a Kotak member and start using Kotak. That means you are churning from your current bank, which is HDFC, and moving into Kotak. So if somebody or you are working in HDFC as a data analyst, then you need to know and understand the pattern of the people who are leaving and joining other companies, right? So this is the use case. You as a data analyst, you got to know there are 10,000 records, out of which let's say 2,000 people are churned, 8,000 are active. Your main task is to understand the pattern. So when you start doing univariate analysis, you analyze each and every column individually. Let's say there is a column called as gender. So what you do is you plot the gender on the original data. Let's say best case scenario, male and female both were 5,000 and 5,000 each. You do the same thing for the churned customers. Again, best case scenario, let's say 950 for male and 1050 for female, which is almost a 1:1 ratio. So the insight that you get here is probably gender is not an important feature. But in case instead of this, you have a graph like this. Let's say male are 500 and female are 1500. Now there is a huge difference. In the original data, it was 1:1. Now it is 1:3. That means out of 5,000, almost 1,500 have churned. So around 30% customers have churned only from the females category. This is a big insight, which means females are more likely to churn. Similarly, we analyze each and every columns individually. That is called as univariate analysis. When you analyze two variables together, that becomes bivariate. Now, an example of bivariate analysis is Let's say you are analyzing gender and location together. You do the same thing on the original data. You find out, let's say male, female. Let's say I'll talk about three countries: France, Spain, and Germany. France, Spain, and Germany. France, Spain, and Germany. Okay. France, Spain, and Germany. France, Spain, and Germany. They are equally distributed. And if you do the same for the churn customers, male and female, let's say here you see a equal distribution, but here you see something like this: France, Spain, Germany. France, Spain, Germany. Now here you get an insight that even though France is less in number as compared to Spain and Germany, here France users are more. That means females staying specially in France are more likely to churn. And that is how you do your ED analysis with individual columns, which is univariate, combine two columns, which is bivariate, and if you combine multiple columns, it becomes multivariate, and finally you get the insights. Similarly, you also analyze different numerical attributes. Let's say you are analyzing age or salary or monthly charges. Let's say you analyze the distribution something like this, which basically means most of the people, let's say you're doing it for the churned customers. So most of the people who have churned are within the age of 15 to 25. Let's say you see a graph like this. Most of the people who have churned are in the range of 45 to 50. So that's how you interpret and get insights using various graphical representation. So concepts like measures of central tendency, measures of variability, graphical representations, and sometimes we also do outlier detection in order to get EDA insights. Let's talk about probability. Now, probability concept is one of the most important concepts when it comes to statistics. Probability theory provides a foundation for understanding uncertain events. There are multiple key concepts when it comes to probability theory that includes events. That basically means the outcomes of interest. There is sample space, that means set of all possible outcomes. There are multiple probability rules: addition rule, multiplication rule, and so on. We have conditional probability, the probability of an event given another event has occurred. We also have various probability distributions like uniform distribution, normal distribution, and binomial distributions. So let's take an example and try to solve some probability related problems. So we'll start with the classic example of tossing a coin. Let's say you are tossing a fair coin. What is the probability of getting a heads? So very simple. The sample space will be head and a tail. The A will be getting a head. So probability of A will be the total number of favorable outcomes, which is 1, divided by total number of possible outcomes, which is 2, which becomes 0.5. So the probability of getting a head while tossing a coin is 0.5. Similarly, what is the probability of getting two heads while tossing two coins? What will be the sample space here? The sample space will be head head, head tail, tail head, and tail tail. If you're tossing two coins, these are the four options that are available: heads heads, heads, heads tails, or tails tails. In which scenario you are getting two heads? The scenario is only one, which is HH. What will be the probability of A? Number of favorable outcomes divided by number of possible outcomes, which is 0.25. Simple. Let's take the game to the next level. Find the probability of getting two heads and one tail while tossing 3 coins. I'm not writing it, I'm spelling it out. Find the probability of getting 2 heads and 1 tails while tossing 3 coins. While tossing 3 coins, the sample space becomes 8, which is HHH, HHT, HTH, HTT. Similarly, TTT, TTH, THT, THH, TTH, THT, THS. Yeah, that's it. That becomes my sample space. So in how many scenarios we are getting 2 heads and 1 tails? We are getting 2 heads and 1 tails in 3 scenarios. HHT, so my A becomes HHT, HTH and THH. So what will be the probability of A? It will be 3 by 8 and whatever the values will be. I think 0.3 something. Similarly, let's try to talk about some conditional probability or probability rules. So let me just erase everything. We'll take a new example. So addition rules are very simple. A union B is nothing but P of A plus P of B. Okay, this is the addition rule, and the multiplication rule is A intersection B is P of A multiplied with P of B. That is the multiplication rule. Now talking about the addition rule, we'll take an example. Let's say the example is, what is the probability of getting either 2 or 5 while throwing a die, while die is thrown. So when you play Ludo or snake game, you throw a dice, right? A dice has 6 faces, 1, 2, 3, 4, 5, 6. What is the probability of getting either a 2 or 5? Now, getting a 2 or a 5 is mutually exclusive, right? So if I have to rule the addition rule, the probability of A is getting 2, probability of getting 2 is 1 by 6, and probability of B is getting probability of 5 is 1 by 6. You add them, this becomes 2 by 6 or 1 by 3. Or if you don't want to use this formula, you want to traditionally use the formula that we used in the previous three questions. Your sample space will be 1, 2, 3, 4, 5, 6. Getting A will be 2 or 5. So probability of A will be favorable outcomes by total outcomes, which will be 1 by 3. That is the addition rule. Similarly, you can also apply multiplication rule given a particular scenario. We'll jump into conditional probability. Conditional probability is a probability of an event given another event has occurred. If this has occurred, then what is the probability of this? Now, if two events are not mutually exclusive, the formula becomes like this: probability of B minus probability of A intersection B. We'll take an example. The example is, let's say in a class there are 30 students. Okay, there are 17 boys and 13 girls. There are 9 people who scored A grade. What is the probability of getting a girl student or a A grader? Now, if you find the probability of getting A grader, it is 9 by 30, but that includes some girls as well. Let's say out of 9, 4 are boys and 5 are girls. So 9 by 30 includes some girl as well, right? So they are not mutually exclusive. So you will be using this formula here. So probability of G or A becomes probability of G plus probability of A minus probability of G and A. What is probability of G? 13 by 30. What is probability of A? 9 by 30. What is G and A? 5 by 30. So if you calculate 13 plus 9 is 22, minus 5 is 17 by 30, and that becomes the output. So different scenarios, we can use different logics. Now I'll also talk about a concept called as cumulative probability. Cumulative probability. Probability. Now cumulative probability tells probability of x less than equals to n is probability of x equals to 0 plus probability of x equals to 1 plus dot 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 probability of x equals to n. This is the formula. Let's take an example. If you are, okay, let's say you are tossing coins. What is the, let's say you are tossing 3 coins. Okay. What is the probability of getting one or fewer heads? One or fewer heads. Okay. So basically it is asking for x less than equals to 1, which will be x equals to 0 plus x equals to 1. What is the probability of getting x equals to 0? If I talk about 3 coins, what will be the sample space? It will be triple H, HHT, HTT and HTH. It will also be triple T, THT, THH and TTH. What is the probability of getting no heads? It is just 1 by 8. What is the probability of getting one head? It is 1 and 2. So 2 by 8, that becomes 3 by 8. So that is your answer. So that is cumulative probability. Now if you ask me, in which scenarios do we use probability theory in data science or data analytics? Well, when it comes to data science, there are many algorithms. One of the classical algorithm is naive Bayes algorithm, which is a classification and regression algorithm which uses probability in backend. Very specifically in probability, it uses a concept called as Bayesian theorem. Okay, so there are some advanced topics in probability. I don't want to get into that, but Bayesian theorem basically means this. So probability of B given A is true is probability of A intersection B divided by probability of B. Similarly, probability of A intersection B is probability of A union A intersection B, probability of A. Now, if you consider this here, so mathematically, if you take probability of A intersection B, which will be A probability of A upon B multiplied with probability of A, if you replace this here, you will be getting the relationship between probability of B upon A, which will be probability of A upon B multiplied with probability of A divided by probability of B. This is called as Bayesian theorem. Okay, now how to read this probability of B upon A? It basically is read like this. What is the probability of B given A is true? Okay, so that's all about probability. Some of the statistical knowledge that we have got from this video, we will be using those statistical knowledge in order to get some insights. So we'll be going through this particular use case where I will talk about the data set, and I will also talk about what are the different steps that I'm going to perform to do this ED activity. While doing this ED activity, we will be using some of the important statistics concepts as well. Now, before getting into the practicals part, let me just quickly talk about the use case. The use case is pretty simple. This is nothing but a customer churn related use case where the dataset is a telecom related dataset. If you look at the dataset, this is how the dataset looks like. We have customer ID, gender, senior citizen, partner. So there are different features. Now, if you scroll towards the end, there is a column called as churn. No means this customer is active customer, this customer is active, this customer is a churned customer. Now, your task as a data analyst or as a data scientist is to identify who are the churners, and who are the churners is just one line of code. You just have to filter the data based on churn equals to yes. But our main target is to identify the potential characteristics of the people who are churning and why they are churning. That is the whole objective of this EDA. While performing EDA in this particular use case, we will be using our statistical concepts and whatever we have studied so far. So to begin with, if you're using a Colab or your local machine, you have to use your data set. I'm using Colab, so I'll quickly get started with it. I've imported all these libraries, NumPy, Pandas, Seaborn, and Matplotlib, expecting you to have some basic knowledge on that. So this is where I'm reading my file, and dot head is giving me the top 5 records of my dataset. So I have multiple columns, 21 columns, and if you look at the size of this data, there are around 7043 records. Okay. So whenever you start working on a use case, especially you are doing the EDA, always get started with the head and few of the regular commands like information, describe, and so on, so that you know something about your data set. How many null values do you have? What type of data types are shown, and so on. In order to check the data types, you can simply do d types and you will be able to get the data types of each column. Now, if you look at the data, there is a column called as senior citizen, which is a numerical object. Tenure is also numerical, and we have monthly charges and total charges, which are also numerical. But if I look at here dot d types, you can see total charges is identified as an object. Now this is a potential problem scenario where you need to fix this problem, because your total charges should be a float object. It should not be a string object. Okay, because if it is a string object, if you don't have any values, even empty spaces will be detected as not null values in string, which is a problem, right? So next I am doing dot info to check the information of the data frame. You can see first it shows that telco based data is a data frame with 7043 entries. Each column information also is being shown, how many not null records, count, and data types. Same, total charges is an object type. Make sure we have to change it to a numeric. So that comes as part of the data cleaning activity. Dot describe basically gives you the statistical information. Now, I hope you know about the median and the mean values, right? So this is where you are getting the statistical information about the numerical columns. Why we don't have total charges? I already explained you. Total charges is object. That is why we are not able to see total charges here. Once we fix the total charges, you can again do the dot describe to know more about total charges. So interpreting the monthly charges alone, you can see the average monthly charges is 64, the minimum is 18, the maximum is 118. So the median is 70, right? So next step, I'm doing a value counts on my target variable, churn variable. You can see the records are 5174 and 1869. Now, if somebody wants to plot the graph from this value counts, it's very easy. You just have to call dot plot at the end and just call the function, and you will be able to plot the graph. And this graph basically shows the distribution of churned and not churned customers. If you want to have a horizontal bar chart, you can also do that. If you want a pie chart, you can also do that. So we are not here to explain you everything about matplotlib and how these plots work, but generally speaking, this is what we do while we do ED. So this is one of the potential steps for data cleaning. I'll write it down as data cleaning. Here, I'm first converting my total charges to numeric, and then I'm doing isNull.sum. So I will do this before doing this, okay? So before doing this, you can see there are no null values. Now I will change it to numeric and again run the same command, and you can see that there are 11 null records. Now, how much percentage is 11? There are 7,043 records. 11 out of 7,043 is just 0.15%. So whenever you have such a low amount of missing values, again the decision is yours if you want to fill the records using mean value or median value. So in order, if you want to fill them, you can definitely use a method called as telco base data dot fill na, and then you just pass the mean value. Let's say the mean value is 23. So you just pass 23 here, right? In my case, I am not imputing using mean or median. For simplicity, I am dropping these records. But you can, this is where your statistics concept comes into picture. You can fill using mean or median. How to calculate mean and median is very simple. You already have the data, total charges. You just have to call the total charges and call the mean value of that. Okay. So let's say we'll also do telco base data dot total charges. So how to calculate the mean value? In order to calculate the mean value, just simply pass dot total charges and then just call the mean function. You can see the mean value is 2283. If you want to use a round function, you can use a round function. My bad. Now this will give you a rounded value. Okay. If you want to use this, you can use this. If you want to find the median, telco base data dot total charges dot median, and then calculate the median value, again pass it through a round object, and then you can impute it like this. Sorry, we have to impute it here. So telco base data dot fill na, and then pass this entire thing, and then in place equals to true. If you do this, then you will be able to impute your null values using mean and median. So in this case, I'm not imputing because it's just 0.15% of data. So I'm deleting it. So once I delete it, then I have to also delete some of the columns that are not required. Customer ID is not required. So I have deleted it. Now I'm left out with a data like this, and assuming there are no cleaning steps, this is where your EDA begins. You can go ahead with univariate, bivariate, and multivariate analysis. So I have just performed univariate analysis as an example. Now here I have written down a code. See, if you simply want to plot something based on a single feature, let's say you want to pass gender, you can simply do sns.count plot. You pass the telco data, x-axis, and a hue. Hue basically talks about the legend. Okay. Now you must be thinking this is a bivariate analysis where you are analyzing gender with respect to churn. No, it's not a bivariate analysis. I'm using churn as a hue, right? So majorly it's a univariate analysis where the insight from this graph is, I think it's well distributed. That means gender is not an important column individually, but gender along with another column could be important. Let's say we'll try to plot contract. If you plot contract, you can see the orange bar is almost very similar to the blue bar in the month to month customers. That means most of the churners are into this category called as month to month. So most of the month to month customers or monthly customers are more likely to churn. If you want to find the exact ratio, obviously you can plot the labels, but if you want an estimated value, let's say around 1600 or 1700, 1600 people have churned out of the total, let's say 1650, and the blue bar is around 2200, 3850 into 100, you can see the churn rate is around 42%. The original churn rate was around 26%. We have not calculated, but we can calculate it using length of telco based data into 100. You see the original churn rate is 26.5%, but from our univariate analysis we are able to get that month to month customers are more likely to churn with a percentage of 42. So if you want to individually plot it, you can plot it, but I have already prepared a small piece of code where I'm running through a loop. So for I predictor in enumerate, I am passing the entire data frame and dropping only these columns because these columns are numerical columns and I don't want to have churn because I'll be using churn as a hue. So once you run this, you plot each and every graph, and then your task is to go through this graph and come up with some insights. So I'll randomly pick one of these graphs and help you with some insights. Let's say talking about tech support. You can see tech support. People who don't have tech support are more likely to churn. If you look at the numbers, probably it's around 1400. This is around 2000. So the ratio is around 1400 divided by 3400 into 100. Around 40% people who don't have tech support, they tend to churn. That's all about EDA. And furthermore, you can also go ahead and do some bivariate analysis and multivariate analysis. I would also like to touch upon again a statistical topic called as correlation. So in order to perform the correlation, I'm just converting my churn into ones and zeros, and then I'm doing some feature encoding where my entire categorical data will be converted to numericals. Once this is done, in this piece of code, what's happening is I am using the data frame calling the core function with respect to churn. So if I just delete it, with respect to churn, what is the correlation? I am finding it out. Now, if you don't know the concepts of correlation yet, correlation is a very simple concept where you analyze two columns, let's say height and weight, and let's say the data points are something like this, which basically means when the height is increasing, the weight is also increasing, which is a case of positive correlation. So the correlation value will be somewhere around 1. If you see a graph like this, which means when the height is increasing, the weight is decreasing, it is a case of negative correlation and the value will be somewhere near to -1. And another scenario where the data points are scattered randomly, you are not able to figure out whether it is an increasing or decreasing trend, you call it as no correlation. I call it as no correlation and the value is somewhere around 0. So here you can see if the value is 0.15, which is not a huge number, but let's try to sort it. Okay, so I will use the sort function to sort it, and now you can see that contract month to month is very highly correlated with churn. Online security, no, highly correlated. Tech support, no, highly correlated. And these things we already interpreted from the graph. You can also interpret using the correlation function. In order to plot this graph, I'm using dot plot. So this is how the graph looks like. So here, if you ask me, I will consider somewhere here and somewhere here as some of our most important EDA insights. So that's all about this particular use case. Covering an entire EDA use case in just 10-15 minutes is not possible. So that's all about it. You can take this use case to the next level by performing further univariate, bivariate, and further analysis. So whoever is still watching, thank you all for watching this video. I hope you had a glance of the various statistical concepts. Please go ahead and practice more and more. If you are looking out for more projects related to data science, data analytics, data engineering, or cloud related platforms, please check out Project Pro. See you in the next video.